Hello? Please answer me, otherwise I cannot, I don't understand whether you are getting things or not. Are you aware of the friend
Yes, sir.
function? So friend function,
Yes, sir.
all of you know the concept of friend function, where it is used?
Yes, sir.
What is the application of
Yes,
friend
sir.
function? Where you have used it?
So if a class needs to access, if a function needs to access some
No, in
private
terms of yeah, that is fine. That is how we try to explain friend function. But what is one way where uh, it is really useful in operator overloading? Can you recall that? During overloading operators, friend function, there is few instances where we cannot do it without using friend function. Can you recall that? Hello?
uh, during overloading of the addition operator, we need two objects of a class.
Sir,
So
it offers better flexibility.
yes, sir.
No, no. I mean a very specific answer. Say I am trying to uh, say say two complex objects or maybe two matrix objects, whatever. Okay, so the first operand, so and I'm trying to add means it is I'm trying to overload the plus operator, say for example this plus operator. So if I write something like m1 equals to 2 plus m2, where m1 m2 are matrix type, so if I would like to have such type of calls implemented, so how this is done? So this gets translated to, so generally what is the translation? So 2 dot operator plus m2. So is that possible? Is it allowed like this? So whenever we make a overloading of an operator, it gets translated to this such kind of special function calls, method calls, right? Hello?
Yes, sir.
Yes,
Yes,
sir.
sir. Yes,
Hello?
sir.
So using that idea, so if I try to think of a translation something like this, will it work? Because 2 dot this, so what is the basic problem? The problem is the first operand is a constant. It is not an object of a particular class type, right? I mean the class type means the one that I am trying to overload. So 2, which class it belongs to? 2 is definitely an object, but it's an object, or which class it belongs to? It belongs to integer class, and you are supposed to overload the integer class, so that is not possible, right? So if I would like to have this kind of syntax 2 plus m2, where I expect that every maybe members of this matrix is added by 2, is incremented by 2, so this is not possible here, right? So the compiler, if it translates something like this is not possible. So what is the other option now?
Operator plus 2 comma m.
Hello?
Operator plus
So we
2
write
comma.
plus, then we write 2 comma m2, and we write here m1. So in this case, so we have got both of these two options, right? But in this case, this option cannot be used at all because the first operand is a constant. So we go for this, and this is how to implement this. Now you know that. So this operator plus function must be declared as a friend function because it is trying to access members, not only public but maybe private also, of this matrix class as well as these two, the value is. So, and why it is friend function? Because, and once it is a friend function, you don't have to invoke a friend function using some object, right? So that is a flexibility. So you don't have to invoke it using two, rather it's just a normal function having these two as an arguments. But if it is a normal function, it will not work, and it need to be declared as a friend of this matrix class, so that through this function you can access the members of that matrix class. So this is where we are forced to use or know the concept of friend function. Otherwise this way of calling or invoking the operator is not allowed, right? Are you getting me?
Yes, sir.
Okay, so these things I think this part Abhijit has taught, and then after that I think Dipanita she has taught the inheritance part, right? So in inheritance, what is the essence of inheritance? What you got from the inheritance part? What is inheritance?
Sir, all the data and functions present in the base class will be uh, inherited to the derived class, and ex-
So in inheritance, why we need inheritance? What is the need for inheritance? In inheritance, because the basic say object one of the basic say philosophy of this object oriented design is to ensure more and more reusability, right? So the more you can reuse your existing stuff, the much better it is, right? Okay, have you switched on the recording? Is the recording on?
yes, sir.
Yes, sir.
Okay, so the point is, so the inheritance, the overall philosophy from which the inheritance was defined, it was like we would like to have more and more reuse of existing stuff. So in C we know that we can always reuse a existing function. In a modular programming, that is in a procedural programming, that is possible. You write a factorial function and you can use it as many times as you want. Also, so that is possible. But in no way you can reuse a particular say data structure. That is not possible, right? So or in other words, in a object oriented concept, when we encapsulate both data and member, so the entire stuff, so the whole thing can it be reused. That was the idea. So this reuse means even before inheritance, what is the way of reusing the code reuse that you understood, that you used? Without inheritance, is there any way of reusing a particular class definition while writing new classes? You have got a class A, right? You have got. So I'm trying to start this before I start this dynamic binding, because today's topic will be dynamic binding. But because I do that, before I do that, I would like to get tuned to the discussion, because there are few classes that which I have not taken, but those concepts will be referred quite often from now on. So let me just have a uh, outline of those. Okay. So in the inheritance, what happens when we have a class? Say I have got a class A, and I have got members, both data as well as methods. Now, so this is already there. Say for example, class A is there. Now I would like to define, or I would like to create a class B, definition of class B. So what way I can reuse? So if I know that there is some kind of reusability that is possible, when I write class B, I can reuse class A, the definition of class A. So what is the possible way of reusing? What is the possible way we can reuse the class A definition? What is the feature through which we can use? That I discussed even before talking about inheritance. We did it in multiple cases in examples. Can you recall that feature? Are you getting my question? Hello?
Sir, are you asking
Sir,
whether
print
the
class.
Yes? Hello? I am not getting you. What is the question?
Are you asking whether it should be public or private or protected?
No, it's not public private. My question is, no matter what, whether it is, yes.
Sir, we can declare A as a friend class of B.
Yes, friend class of B. So see the friend, if A becomes a friend of B, does it mean I'm trying to reuse this? A is a friend of B.
No.
So if
No,
A is
sir,
a
we
friend of B,
cannot
so then
direct.
A can, if A is a friend of B, then A can probably call the members of B. That's all right. But my question is something different. So there is some A, and I'm trying to create B. You have got the class, say an engine, a wheel, and now we are trying to design the class car class. So definitely when you are trying to design the car class, you can reuse the existing classes like wheel class, engine class, right? So what is the way we can reuse it? What is the feature that helps us? Don't take so much of time. I think we have discussed about it in much details.
So
Nobody in the
nested
class.
classes.
Yes, hello.
Nested classes.
Yeah, but it is not pure nesting. It is there's another term. Uh, can't you recall the concept of composition? Composition. Can you recall what composition means? Hello.
Yes, sir.
So if it happens so, like a car is composed of a wheel and an engine, say in this case say B is composed of A. So B in the class B, I say that there is a, so B is composed of say 5 objects of type A. It may have something else also. It may have something else like int z also. That is also fine. But B is composed of, you see, 5 instances of A, or maybe 1 instance of A. So when you are trying to design B, you are trying to reuse the definition of A that is already there, and this is what is called composition. Can you recall this?
So that means class B is having a has a relationship
Yes.
with A.
So it's a has a relation. So this is one way of reusing, because the one of the major headache of the designer in object-oriented design is that how to write less and get the most of it. How to have a nice design which evolves from the existing stuff. So whenever you are asked to write something, you should look for, okay, can I use something that is already there? So the first thing you should see that whether this new class is related to the existing classes in terms of what are the two options, is a and has a relation, right? Can you recall this?
Yes, sir.
So has a, we have already extensively we have discussed during my lectures, right? Composition, like the linked list is composed of nodes, and then the hash table is composed of linked lists. Can you recall this, or it's all everything went off during this month time? Can you recall others, all the other students?
Yes, sir.
So that is one way of reusing. Now what Dipanita did, I mean, in your last few classes, she taught about, or she discussed about some other way of reusing. What is that? It is ISA. So the ISA is, I mean, I think she took some examples, several such examples. Say we have got, say for example, there are many examples. Say the room, we have got a classroom. Okay, so we have got a classroom in our building, in our CS department. We have say 3-4 classrooms, and if you are asked to create a database for the computer science building, I mean database means a software that will include all the say objects of the computer science department, the building. So you say that, okay, the classroom is one particular, so there are multiple classrooms, so classroom should be a class. Okay, so room should be a class, or lecture room should be a class. And now you know that, okay, in the lecture room we have got these items. So these are the data members through which you can specifically store those characteristics. And you know that, okay, you can take class and you can do these things, take exams also, those rooms like this. But now with time, if the decision is taken that, okay, some of the classrooms, see, classroom is already there or lecture room is already there, some of the lecture rooms will be converted to seminar rooms. Okay, or maybe smart lecture rooms, something like that. That means it is not that all the lecture rooms will be converted to smart lecture rooms, but few of them. So the pre-existing lecture rooms will be there, and you are going to create, you are supposed to create as a designer a new class which is called smart lecture rooms or smart lecture halls, right? Now these smart lecture halls, as it was mentioned, that some of those existing rooms will be converted to it. So that means they will not be destroyed. So whatever the room is there, whatever the features, the chair tables, all there, you add some additional stuff to it to upgrade it to a level of smart room, right? So that means in that case, so if you have got a normal lecture room, so and you are trying to create a smart lecture room or smart lecture room, so these were already there. So this class design is there, the class is there. Now the smart lecture room, now you can say that, okay, so this smart lecture room, it is a, so it's a specific type, so it is a lecture room, right? So there are lecture room objects, but there are smart lecture rooms which are of this type. And sometimes maybe a lecture room can be converted to some other, maybe meeting room also, something like this. So this is a kind of is a relationship. So what is the difference between this has a and is a? So this B, it says that it has a object or multiple objects of type A. And what is the difference between the is a? In the is a kind of relationship, the thing is you can, so when you are inheriting something, see for say for example, you are inheriting your father's car, say for example, you are inheriting. So what you do, you can just use as it is, but generally when you inherit, you try to, at least you have to know, you have to change your registration name, because you have to make it in your own name, so that part need to be changed at least. Okay, so few things definitely will be changed, but if you want, you can upgrade something, so you can add some few more stuff in that uh, for some more features. So when you inherit, you may accept the inherited uh, class design or the inherited objects as it is. If you wish, you can modify parts of it, or if you wish, you can add some completely new stuff to it, right? So that is in real life world, in real world also, inheritance means like that. So if you inherit a house from your parent, maybe a two-storied house, so once you get it in your name, so that's the first thing that you do, you leave it as it is for maybe a few months, then you make one more story, so maybe the second or the third story you make, so you add that stuff. And then the ground floor that was there, you may be willing to change the flooring, so you basically modify some existing stuff. So some stuff that is there, that was already inherited from your parent, you try to modify it. Okay, floor remains the floor, but the floor material gets changed. You add a new story completely, so you add some stuff to it, and few things you just leave as it is. So that is a kind of change. So the thing is, instead of completely trying to write a new class in case of inheritance, which is actually modeling is a relationship, the one from which you are inheriting, in this case lecture room, the lecture room may be modified, some of the components of it, maybe the blackboard, you remove it and make it a whiteboard. And because you are adding whiteboard, you just add a projector, so that was not at all there. So the projector you add, the board you just remove, so you just modify the board, and the rest of the chairs and tables they remain as it is, right? So that is what you do, and that makes it a smart lecture hall. So is that part clear? So why I'm talking about this, because we'll be using and referring to these inheritance features during this dynamic binding. So do all of you agree with this? Because this has been taught. Is that part clear completely? Hello?
Sir.
Yes, sir.
Yes, sir.
Is that okay? So now, as you can see, there are a few quotes that it was copied from the book by Bruce Sickle. This volume 1. So there are a few interesting stuff. You can see here that the polymorphism implemented. So apart from the data abstraction, so data abstraction you already learned much before. I mean, in the first few classes, and then recently you studied inheritance. So these are some very important or essential features of object-oriented programming. But this polymorphism, that is using the virtual function, this is going to be the third essential feature of object-oriented programming. So which we are going to learn, right? And it says that this virtual function enhance the concept of type. So what type is and why it is required, we'll talk about that. But it says that if you don't, I mean, there is something very strange statement that he makes, that if you don't understand virtual functions, you don't understand OOPS at all. So that is something very serious remark. So the rest of the stuff in that you have learned till date and learned to use the features, they seem to be quite obvious and naive like features, but they're important, essential. But it seems so that this virtual function is something that is more appealing than others, and uh, in fact these kind of stuff helps us in writing more generic codes. And from the user's perspective, when I use your code or your classes, it becomes easier for me to extend the code and all this and use it also. So this virtual function, in the dynamic binding, this is a concept of virtual function that we are going to study, and we are going to study why it is required and how it is internally implemented. That is also important. It's not only just placing just to know that where should I place a keyword virtual and it will work, right? And the features in procedural programming can be understood at the algorithmic level, so that it is more or less true. But this virtual function or upcasting, so this is also another term that we'll encounter during this while discussing about this topic, can be understood only from the design point of view. So this is not uh, related to the algorithmic part, or I mean design of the procedures and all this. It's more related to the overall design. And there are certain like debate that exists in the academic community in the so like, if you are given with a problem, so will you go for multiple inheritance or will you go for the reason such debate arises, and what probably will be your conclusion or what will be your choice in such a case. Okay, so this outline I just want to start a bit, in a bit slower pace, because uh, yes, as I mentioned, like the inheritance I have not taught, so I would expect you to go through it once, uh, maybe before the next class. In fact, I took the classes the last year, because uh, that was the only batch. So I mean, we took it in the physical mode, so everyone took the entire batch. So that's why I took the classes. But this time we are sharing it, so that's why uh, the entire topic is divided into parts. So before I start, so this will be the overall topics in the dynamic binding. So how many of you have heard this dynamic binding? The term I think is not new, right? We have already mentioned the concept of dynamic binding. I have mentioned it in my previous classes, in some of my earlier classes? Can you recall dynamic binding? May not be in the context of this inheritance and all this, but can you recall dynamic binding to some extent? Any of you on the class? Hello?
Sir, when we were using the array of function pointers during
Yes,
that time.
function pointers. I think others also they can recall it once you are given a hint of it. So while discussing about function pointers, we came up with this term, right? Dynamic binding. But this is another context in which the term dynamic binding or the feature of dynamic binding will be used, and it will be used in a very interesting way to see that. I mean, there is again some kind of magic gets into, and because magic means it is abstraction, and in a object oriented terminology you call it as a polymorphism, like that. So we'll see that how this dynamic binding feature which we saw while discussing about function pointers can be used or extended here in some other way to achieve another degree of polymorphism, because polymorphism is something that we try to achieve in your real life. I mean, it is quite inherent, and in object oriented design also we would like to achieve or implement polymorphism in multiple ways, like function overloading, operator overloading, and this will be one instance of that. Okay, so I'm trying to give you the overview of what will be there in this particular topic. So we're talking about typecasting. So typecasting you all know, right? Typecasting, implicit typecasting, explicit typecasting. You may not know the much details of it, but I think typecasting is a known fact. So sometimes you have got 2.5 and you would like to typecast it to an integer. If you are trying to assign the value 2.5 to an integer variable, now you know that this 2.5, the 0.5 will be automatically ignored, and the value 2, the integer part, will be actually copied in the integer variable. So this gets automatically casted. Okay, so casting is also something like so in our real life casting happens in the films. A normal person, the same person acts or behaves for the temporary uh, moment he acts differently. It's like that. So you'll see that the difference between implicit and explicit casting. We'll talk about the static binding. You already know it's a default one, but the dynamic binding we will have you got the flavor of that. We'll have once more. We'll talk about it, and we'll see that how this dynamic binding this can be used to achieve or I mean this virtual function achieves dynamic binding. So this is a new word, new keyword that you will be learning in this particular class. And then we'll talk about polymorphic type or polymorphic objects. Okay. And there is something interesting, that is virtual destructors. You heard about constructors, destructors, everything is fine. Copy constructors, all these are done. But now sometimes the destructor needs to be virtual. So if it is, so we'll see that if it is required and when it is required, what is needed. Anybody of you heard about virtual destructors? Virtual function, many of you have heard probably, but have you used virtual destructors till now? Hello? Any idea? Okay, so another is virtual function. So as I mentioned, so we'll start with typecasting, talk about different types of binding. We'll review the topics, and then we'll talk about the dynamic binding, how it is related to virtual function. And after talking about virtual destructors, this is under the hood, means we'll see that how internally it gets implemented, how the concept of virtual function gets implemented internally using the v table and v pointer. Virtual table and virtual pointer. And then we'll discuss about the pure virtual function, the abstract base class. And these are some quite useful terms as well as features which will be used in our object oriented designs quite often in real life design, object oriented design. We quite often will encounter such things. And finally, the multiple inheritance. So multiple inheritance, it has been, I think, uh, the underlying concept has been uh, discussed in your previous classes, but how this gets implemented and what are the issues in implementing that, whether we in our design we should allow or will encourage a design having multiple inheritance, or whether we go for a different alternative. So that also we'll see. So here actually involves the debate, right? So that's outline. So let us now start, maybe a few slides I discuss about. So first we start with the typecasting in C++, the implicit and the explicit typecasting. So these are simple things. I think most of you already know this part. So typecasting is a process of converting one data type to another. Okay, and this implicit one, this is done by the compiler of its own. So what is the example of it? So we have got one I and j, these are integer type, and one is a double, that is 8.9. So one is a double, and when I write 8.9, what do you think? Is 8.9 is so this is not compatible, but this gets. So what is the problem here? When I assign 8.9 to D, is it trivial?
No, sir.
So 8.9 is a floating point type, but when I do this, will the so there is a type mismatch, right? 8.9 is not of the same type as D. So what we generally would expect, that the compiler should start shouting and it says that okay, you are not having suitable types, but it is not so. If I just write it, it will be okay with the compiler. So why it is accepting it? Because for the time being 8.9 is casted as an integer and assigned, or as a kind of double type, and it is assigned. If I write I T I, so are they same? See, D is double type, I is integer type. So if I look into this, they are also not identical types. But here also if I write D assigns the value of I, it is allowed. So these are examples, I mean the trivial ones, these are the trivial cases that we already know. These are examples of implicit casting. Why it is implicit? Because the compiler on its own performs the casting. You don't have to write any or you don't have to use the typecast operator. So what is the typecast operator? Is this one, right?
Yes, sir.
So this typecast operator, if you do some casting which is not generally allowed, you can use a typecasting operator to force it to be casted, and that is what is called explicit casting, right? Explicit typecasting. So this is a feature through which it is performed with a programmer explicitly using typecasting operator. So through using this operator we can typecast it. So this is another example of implicit typecast, where this 2.0 divided by 3.5, this is a floating point value which you are trying to assign it to an integer variable. So normally the types do not match, but we know again implicit typecasting, the result value gets converted to integer type, and the compiler does it on your behalf. In this case also, this D, I by D, so this is a floating point type. So the thing is, this I gets converted to double type, and then the double gets divided, it becomes a double type, and then it is assigned to it. So this is also implicit typecasting. So if I write this, will this be allowed? I'm trying to assign the address of a floating point value. You see, address of a floating point variable, I'm trying to assign it to an integer pointer. Will this be allowed?
No, sir.
So here, as you can see, so in the all the previous cases, this implicit typecasting worked, but here this implicit typecasting fails. But now, if I use this typecast operator, I can force it. So if I use a typecast operator, I can force this conversion. This casting can to happen. So that's why this is called explicit typecasting. So we already know a lot about pointers. So if I force it, so do you think the compiler will accept it? First of all, if I just write it like this without casting, it will not work. But if I just do it explicitly, will it be allowed? Will it be allowed if we go for explicit typecasting?
Yes, sir.
Sir,
Should
it
be
is
allowed.
allowed, but sometimes it will become ambiguous.
And sometimes it's not sometime, but this is dangerous, right? It may be dangerous, and it should not be used, because we know that floating point variables, but in case of like the kind of compiler that we use, maybe the float and integer both occupies the same number of bytes. But even though it's same number of bytes, by interpretation of the content of the zeros and ones stored in that location, if you interpret it as the entire thing as an integer, and if you consider a floating point, we place it somewhere, so the interpretation will be different. So you may not get the same result if you do so. So in some cases it will work, some cases it will fail, but it is definitely dangerous to force it to be typecasted like this. And if I do so, so explicit typecast attempts fails. This is an error message. So what is this? What is this here? A floating point value is casted as an integer value. Hello? So if a floating point value is casted as an integer value, we know that in C compiler, in many C compilers, integer variables take 2 bytes, and floating point variables take 4 bytes. So in such a case, if you try to typecast it, maybe that you lose some kind of precision. Okay. So the main thing that we try to highlight through these examples are, in many cases the compiler, if it is meaningful, the compiler performs implicit typecasting, and sometimes it will not allow implicit typecasting, something like this. And in those cases, if we go for explicit typecasting, this may be dangerous. Sometimes it is losing the precision, sometimes it is trying to recover, through the pointer, it is a completely wrong value that you retrieve. So this is not, so explicit typecasting is not always recommended at random. So one need to be careful while doing so, explicit typecasting, right? So now we'll see that how, so earlier what we did, so integer, float, double, all this. So these are all say predefined classes or predefined data types, and based on that we found that how implicit or explicit typecasting works in this situation. Now we'll see that how this implicit explicit typecasting works in case of user defined data types. Okay, so what it means, there are two user defined data types, and we have taken into consideration here the class SI and the class AU, which are in some sense meaningful. What actually they store, so object of SI will store the length maybe length between two planets or length between two heavenly bodies, kind of. So they need to be stored in SI units. So SI class will have some data member which is capable of storing the distance between two planets or two objects in SI units, that is in meters. And AU actually stores the distance between two heavenly bodies in astronomical units. So the unit length is, so 1 AU is equal to this value. So it's a typically large value. So if you store the length of the, in AU units, that means you require less number of digits, right?
Yes, sir.
Hello, sorry. So it is quite obvious to understand that if you store a particular distance in AU unit, you will require less number of digits, say for example, and if it is in SI, it will require more number of digits. That's why I have tried to declare it as long int. So SI length in SI is long int, and length in AU length is in just integer units, because it will be divided by this value. So that these number of units is just 1 AU. So that's a simple thing. Now the main thing to notice is that this SI class and the AU class, these two are no way related, right? No way related in the sense, so this is a class and this is a class. So they do not they are not related. Okay, just a minute. Hello, হ্যাঁ আসতে পারেন আপনি, আছে, হ্যাঁ হ্যাঁ আছে, আপনি 6-7টা নাগাদ আসুন, ঠিক আছে। Sorry. Okay, so these two are not related by has a or is a relation. So there is no such case. So they are completely unrelated, or they are not related to each other in terms of the design. So the basic question is now, can I, so it's something like the float double int like this. So float double int also, they are not related to has a or is a relationships, right? And we are trying to explore that whether we can whether a floating point value is automatically casted, can be automatically casted to integer and vice versa, and a double value can be automatically casted to float and vice versa, like this. So here also we'll do the same. The objective is to see that whether a object of, you see, the object of this type, AU type, can be casted to an object of SI type, and vice versa. Or in other words, a pointer to AU class, can it be automatically, will it be automatically casted if assigned to a pointer to SI and reference, right? So got the the situation that we would like to discuss about. So we'd like to see that once these two classes are there, the blue classes SI and AU, and once we have, what are these, S and U, S and A, these two are objects. So we would like to see that whether the S can be assigned to A and A can be assigned to S, and these two are what, this PS and PA, these are pointers to these classes with some specific, say, address of these objects we have assigned. So now we would like to see that whether PA can be assigned to PS and PS can be assigned to PA. So whether assigning objects of one type to another unrelated class is allowed, whether a pointer to a particular class can be assigned to pointer to a completely different class, no way related, will that be allowed or not, and also if the reference of a particular class can be assigned to a reference to some other class which is not related at all. Is that part clear? So that we'll like to see, and we'll like to see that why I mean the situations when it is allowed or not. Is that okay? Are you getting me? Hello?
Yes, sir.
Yes, sir.
Okay. So you see, just to see the, if you'd like to visualize the space allocated for object of type SI and AU, as you can see that AU requires less number of space, less amount of space, because it is representing a higher unit, and this is representing a smaller unit, so it will require more space. That is what it means. And SI object S, and this is the AU object A, and these are SI pointers. So this is a pointer of type SI, and this is a pointer to type AU. So this is what we have actually allocated. So SA and PS and PA, S and A and PS and PA. So these are the facts. And then if I write S, A assigned S or S assigned A, so what do you expect in these two cases? Will it work? I have already given the answer here. So implicit casting of object, that means if you try to assign S to A, the value of object S, the bits stored in this object S, if you would like to store it in A, or this contents of A into S, will this be allowed? What do you find here?
If it's a primitive data type, it is allowed, but for user
Yes,
defined,
but no, I'm just talking about the unrelated type right now. Unrelated type, and also, okay, unrelated user defined type. Unrelated user defined types. Then will it be allowed?
no, sir.
Any unrelated user defined types, the objects of two different classes cannot be assigned to each other, right? You can try it also. So implicit casting of object fails. Okay.
Sir, unrelated in which sense, sir?
As I just now mentioned, they are not related to by has-a or is a relation. So these two, they don't have, say, SI is a kind of this, or SI is a kind of this. Are you getting me? So this means they have some kind of relation in the design. So this is not the case. Are you getting me?
Yes, sir.
Okay. So now, so this will fail definitely. So this is not allowed. So error no match for, so it will show that if you compile it, error no match for operator this. So why it is not so? Because if you write S assigned A, so maybe they are the object. So if I write this, what it means, what it will trigger, if I write S assigned the object A, so what it will trigger, what kind of function call it will trigger,
Sir,
what
S of
happens?
A,
Which one?
constructor.
No, it is not a constructor. So we are not declaring, we are not trying to assign values to A while constructing it. So this is completely in isolation. So it just writes after some other steps I write S to A. So what kind of function, or I mean what kind of function it will trigger? Anybody else? What do you think? What goes under the hood? I mean, what is done in internally when you write something like this? What is the operator here? What is this operator?
Assignment
This is assignment operator, right? So it's an assignment operator. It has got two operands. So what it will do? It will invoke S dot operator assignment A. Something like this. Hello.
Yes, sir.
Yes, sir.
So now the problem is when you write this, so this will try to, so when it says that, so this operator, assignment operator, when you overload it is in, when you overload this operator in the SI class, what you write, it's a assignment operator. So you expect here what to be passed, object of the same SI type, right? So here this operator, assignment operator, would expect a object of type SI. That is what you would expect as an input, right?
Yes, sir.
And this A that you pass here is not going to satisfy this, because A is not of type SI. So here it fails. So there will be some type of error. So that's why you will find that error, no match for operator, this assignment operator function. That means you have not mentioned this operator overloading of this operator when an object of type AU occurs. If you have done that, it would have done, but otherwise, I mean, without writing it explicitly, it will not work. And in fact, when you write a different class, it is not possible to guess that what can be the other user defined class types, objects which you would like to assign. So it is not possible. So in that sense, so you can say that this will get a mismatch and it will not work. So it will not work here, it will not work here, because in both ways they are the same.
Sir, but in case of primitive data type also, the interpretation will be the same, no sir? Means how come it
No,
is
as I
working?
mentioned, so in case of primitive data type, that is allowed, but in case of user defined data types, this is strictly not allowed. And in fact, as you can guess, like there are certain cases where it is not allowed also. Like in this case, you are dealing with integer pointers, and here this is not allowed.
Yes, sir, but when you write d is equal to I, it will be the same interpretation
Yes.
by the compiler, no sir? It will expect a double
No,
type.
that is what I mean. So when you write this, maybe when you are designing the compiler, you can make because the ones that you define, it is already known. I mean, the compiler designer also knows that these are these data types, the definition of these data types I'm supplying. So for that I know. So I mean, how it is not, I mean, how it is possible, say to intuitively know how it can work. So a predefined data type, you know, there are some finite set, right? So in float, so there may be, so these are the possible, say, predefined data types. And how to make it possible? Now you know that integer, so when you write the integer class, see for example, integer, this is float, this is double, this is long, like this. So when you write the integer class, as I mentioned here, so you write that, so if it is operator this, so within the integer class you are writing operator this. When you when you pass a float, how it will copy. When you pass a double, how it will copy. When you pass a long, how it will copy, you can write it. In the double also you can do the same. Operator this, if you pass an integer, what it will do, if you pass a double, what it will do, so sorry, if you plus a float, what it will do, and all this. So you can, because this is after all finite, right? And you can probably have an extensive, exhaustively you can consider all the possible cases that these will be copied, these will be copied. And if you find that, okay, this should not be copied because it does not make sense, you can exclude that part. So because when you are designing it, you are dealing with a finite set, and that's why you can do that. Are you getting my point?
Yes, sir. So in
But
order
when you come up with this user defined, it can be anything. So if in your particular, say, application, maybe for this one also, you may decide that, okay, I'll allow this. If you would like to allow, so say implicitly this is not allowed, but if you'd like to allow this and this to happen, so it's just to add operator, say assignment operator overloaded in SI. in such a way that it will accept AU and it will define that what to do, because these two the spaces are also different. So you should know that what it means. So you have to yourself define it. Otherwise, just accepting it can be something disastrous, right? Because you are trying to assign this green one to this one. As you can see, how can you fit this big one into this small portion? You have to truncate something. So it's better you explicitly mention that, okay, if it is so, you do it like this. Are you getting the point?
Yes, sir.
So the thing is, if you want explicitly this to be done for few cases of your application, it is fine. But in general, for user-defined data types, which is unrelated type, the compiler will not allow you, because even in the backend, there is no such codes written, and it will stop doing things like this. Are you convinced? Hello?
Yes, sir.
So next comes this one, like implicit casting of pointers. Pointers means these are the two pointers, PS and PA. So I'm trying to assign this value to this and this value to this. So will this be allowed? So this also will say it will fail. And in fact, this does not. This is not allowed even in the user like predefined classes also, right? Integer pointer cannot be assigned to a integer pointer value cannot be assigned to a floating point pointer, and vice versa. So definitely there is no question of expecting this to work, right? And using this s dot siln and a dot auln, so using these objects you are trying to display the values of these methods members. So this is fine, so you will get this and get this. Or if you would like to do it using the pointers using PS, you will use an arrow siln, pa arrow auln. So this also is fine. So these two are trivial. Now the point is, if I typecast it as we did here, a floating point value, a floating point variable's address, if I typecast it to integer pointer, then it can be assigned. So here also the same thing works. If you typecast a PA, which is a AU type, to SI pointer, it can be assigned. Okay. So we can force it to work. But if we force it to work, and if I use the PS, so you see this PS, in this case, after this assignment, you see, after this assignment, so now PS, what is PS? PS. This PS is pointing to what? After this assignment, this PS is pointing to where? PS is pointing to PA's value. So what is PA? PA is this A. So basically, maybe PS is actually pointing to this one, which it is not supposed to, right? And PA is basically pointing to this one, which also it is not supposed to. So even if force it to work, now this using this PS, if you write PS arrow this AULN or PA arrow this, so will this work? So PS, so what this PS can know? So PS means it is SI. So PS can only write PI PS SILN. You see, PS you can write SILN only, because PS knows PS is a pointer of type SI class, and it can only refer to the data members of SILN, I mean SI class type. Are you getting the point?
Yes, sir.
So if you write PS arrow SILN, because PS can only recognize SILN, because PS is of type a pointer to SI type. SI has got only this member SILN, but it is actually physically it is pointing to this blue one. So physically it is pointing to blue one, but by calling SILN, I mean the name SILN, that means what it will do, it will try to access, maybe it will try to access this much of area. Okay. So you'll try to, so automatically it will be reading some garbage here, and that's why you see there is a minus this value, that's a garbage. But when PA actually points to this location and trying to access this AULN. So that means what? So PA may be actually referring to this portion. Okay, so it gets somehow 12. So whatever it stores, we should not be happy with whatever it stores, because this is anyway it is garbage. So the output in both the cases is garbage. So what I mean to say is, in case of unrelated user defined classes, a class object, an object of a particular type cannot be assigned trivially to the other type. Does not make sense. If you would like to force it, you have to make the changes in the classes themselves. If you would like to assign the value of a pointer to one, from one to the other, this is also not allowed, except you want to explicitly typecast. And even if it is explicit typecasting is forced, but it may lead to some dangerous outcome. Okay. And so this is the last example. Then I'll just, or may I stop it here? May I continue for another 5-7 minutes, or stop it? Hello?
Continue, sir.
Okay. So let me continue for at least these 2 slides. So now we have got, so typecasting with class hierarchy. Now you see, earlier we talk about typecasting with classes which are unrelated. Now we talk about typecasting within class hierarchy. That means what? That means we take this case. So this is B, that is a base class, and this is D, that is a derived class. And this derived class, this D is derived from B, or we say that D is a B. D is a type of B, which is a more specialized class. It's a kind of smart room, a smart lecture, which is derived from a normal lecture hall. So now when 2 classes are related by a is a relationship, in that situation, if I would like to say assign an object of this derived class to base class and vice versa, what will be the reaction from the compiler? If I would like to store the, if I have declared pointers to the base class and pointers to the derived class, and I'm trying to copy the contents of one pointer to the other type, then what will be the reaction? Or I have declared a reference of this base type and the reference of this derived type, and I'm trying to assign each one to the other, what is going to happen? So that is the case. So in the first case, what we started with the predefined classes, and we saw that forceful typecasting is not always recommended until unless you are sure that it will not lead to anomaly. With unrelated types also, if you force it, it is not good, it might be dangerous. In case of class hierarchy, where it has got a easier relationship, whether we accept it or not, let us see that. Okay, so here this is an example. This is a class B, and this is a definition of class D. So this is class B. Class B has got one data member B1, and in fact we deal with all of them as public. Right now, all the data members, let us consider it to be public without loss of any generality. So this is B1, a data member, and this is, as you can see, this is a constructor and this is a destructor. Okay, and the constructor just takes a default value of this argument, and it assigns to this data member. And this D is a class derived from B publicly, as you can see here. So publicly inheritance means, that means anything that was available public to B will also be available public to this class D. Is that part clear? So then public D1, so what I do here, so when this D inherits the features or the properties of B, which is a parent class or the base class, and this is a derived class. As you can see, definitely this B1 is available here, but it has its own D1. It's the third story that it has built, apart from the stories that its parent has got, something like that. And then, as you can see here, I think this part has already been discussed by in your previous classes. So if I think of an object of type, say B, so this we call it as a base object, and object of type D is called a derived object. Okay. So now the point is, in this derived object, because you have got some portions inherited from your base class, that means it has got a base portion and it has got a derived portion. And all we know that if you are trying to construct a derived object, you have to first construct the base portion, and then you have to construct the exclusive portion, the portion that is. So the thing is, when you construct this object D, you basically construct the green part first, and then you encapsulate that as a part of it in the blue part. So first this part need to be done, and then this part need to be done. And to do so, as you can see, that to construct the base part, you need to pass some argument, and for its own part, which is exclusive, it needs some argument, it needs some value. So that's why in the constructor of the derived constructor, the constructor of the class D, which is a derived class, we have passed two arguments. Fine. So two argument, one of them we can use to assign values to the green part, which it inherits from the base class, and the other part, the other value that it can use to assign in its that is exclusive to it. So this member D1 will take maybe say Y, and this B1, which is a part of it, will take the X, value of X. So once this is done, as you can see, so this part is fine. So, and in fact we have not used any other additional functions for doing so. So now what is this? PB and PD. PB is a pointer to base class and PD is a pointer to derived class objects. We have just assigned the values of the addresses of B and D into it. That's fine. And using this PB, so PB is a base class pointer. So using PB, so what PB can recognize? PB can access B1. That's all. What PD can access? PD is a derived class pointer. So PD can access B1 and also D1. So that's why PB arrow B1 we wrote, and PD arrow B1 and PD arrow D1 we wrote. Okay. And in both the cases, in the first case you see we have got the value 2. That should be the case because PB is pointing to the object B, which is storing 2. So we'll get the value 2. And PD is a pointer to this derived object which stores 4 and 6. So if I write this and this, it will store 4 and 6. It will display. So this part is fine. So this is trivial, in fact. Now what about this one? What we are trying to do here? We are trying to store this value. We want to copy it here. Will this be allowed?
Yes, sir.
So give a pause and think. Earlier, if they are not related, will this be allowed? If they are not related, in the previous case, AU and SI.
Not allowed.
Is this allowed? You see, it's error in both the cases. Now, when they are related by this is a relationship, are they allowed? Can you see what is happening?
It is allowed.
So this is allowed. However, if I write this, you see, this is not allowed. So the point is, this is allowed, but this is not allowed. And this is very important to note, because from this the actual concepts will start. So in words, what we can say, what is allowed and what is not allowed? What is allowed in terms of pointer assignment in case of
Upcasting.
hello?
Upcasting.
Upcasting. So the term is upcasting, but to be more in details, what we can say, if we assign the value of a base pointer type, sorry, if we assign the value of a derived pointer type, this is a derived pointer. So this is a pointer pointing to any, capable of pointing to any derived class object. That means these blue objects, right, of type D. So the contents of these type of pointers, these contents can be assigned to base type pointers. So this base type pointer can point to any green objects, just green objects, pure green objects. So the values stored in the blue pointers can be stored in the can be stored to the green pointers, but the values stored in the green pointers cannot be stored in the blue pointers. Okay, earlier it was not possible in any case, like if it is unrelated, but now it is possible in one case, but is not possible in the other case. So the one that is allowed, you see, you are basically casting. Now this is also casting, so it is allowed means this is a kind of implicit casting. So this implicitly casted, so this one is casted up. Why it is up? Because in the hierarchy, if I draw the hierarchy, B is up and D is down. So that is the way we design it. So that's why assigning D the contents of pointer of derived type to the base type means as if you are casting the value or the address value upwards. So that's why it is called upcasting. Okay.
Sir, but why only upcasting is allowed?
Yes, we'll come to it. So gradually, one by one, we'll come to it. But for the timing, you know that this upcasting is allowed. I'll come to it. The details. I mean, here it starts. The actual the chapter starts from here at this point. Okay. And this is not allowed as we found. This is, sorry. So let me put it in red. So this is not allowed. Now, what about this one? PD. What does it mean? PD is what? PD is a derived type pointer, derived type pointer value. And what you're trying to do? Ampersand B. What is B? B is a base object. So base objects address generally it is not allowed, but we are trying to forcefully cast it. So this is forceful casting, forceful downcasting. Explicit forceful downcasting, it will work because knowing that the compiler is not allowing it definitely means there's some danger in it. But if you are forcing it, it will allow. It's up to you. Compiler says that it's up to you because I have not allowed it. So it is non-trivial to show, non-trivial to know type in runtime. So I think better we'll discuss it why it is not possible later on. So now if it is done, say for example this is done, so if you explicitly do it, it will be allowed. Now once it is allowed, PD, what is PD? PD is this one, and although it is not allowed, you have stored the contents of PB to PD. So now this PD, what values it can refer to, what members it can refer to? PD, it's a pointer of derived type.
Both base class member and derived class member.
No, I mean in terms of specifically member names, what it can refer to, it can refer to B1 and D1, because you see the derived class can have two members, B1 and D1. So PD, whatever contents it has got, whatever location it is pointing to, it can refer to B1 and D1 from that, right? If it writes PB arrow B1, you can get some value, right? You can get the value 4 here. You see, you're getting the value 4. Now what is the value here? I think this and this 4 is this one. No. What is the value it is displaying? What is the value PD arrow B1 displays? PD arrow B1. So this is 2. So that's why it is giving 2. Is that fine? But can I write PD arrow D1? PD arrow D1 after this step, after this assignment. After this assignment, can I write PD arrow D1? Are you getting my question? At this point, PD is a derived pointer which is pointing to, it has copied this value. So PD is pointing to this one, right? So PD is pointing to this one. And PD knows I can call B1 or D1. I can refer to B1 and D1. So if it refers to B1, this is fine. It displays 2, fine. But if it writes PD arrow D1, which part it is referring to now? If I write PD arrow D1 after this step, that means it is referring to something like here. Does it carry any meaning?
Sir, we will get an error.
Yeah, so there will be some error, so it's better not to attempt it. So that's why I mean, even if you allow it, it will not, because maybe the codes in the functions you write, because you know that through the PD you can refer to B1 and D1, but here this D1 does not exist at all. So it will give some error message, and sometimes it may be giving a segmentation fault. So that's why it is dangerous and it does not make sense. But if you do the upcasting part, so through this pointer, which can only refer to B1, means it can refer to a small portion of a bigger value, or it can refer to a small portion of a bigger amount, bigger chunk. That is fine. But here the actual chunk is small and it is capable of pointing to a bigger space, and that creates some kind of ambiguity. So maybe you can consider that to be the reason why upcasting is allowed, but downcasting implicitly it is not allowed. If you explicitly do it, it is up to you to accept segmentation faults if it happens, right? Is that fine?
Sir, in the above step where we have done upcasting, if we try to print PB arrow D1, will it work, sir?
No, it will not work. See, the point is PB, does it know D1? PB, does it have any knowledge of D1? Because PB is a pointer to green type. So green type, it knows that green type means just one member called D1. Is PB at all aware of D1?
Sir, after doing upcasting, sir.
No,
PB
after, even if it is upcasting, so that the nature of PB is not changing, right? The nature of the pointer is not changing. So the pointer is a base pointer. Base pointer means it can refer to base members itself, base type members. Even if it is pointing to a derived object, it can only refer to the base portion of that derived object. Is that okay?
Yes, thank you, sir.
Because it is quite obvious, because you are capable of knowing, say for example the hostel manager. So the hostel manager can store the address of the entire hostel, like the room, the common room and all this. But you as a student, you can store only room addresses, that's all. So if you store the room addresses, and if somebody asks you to store, somebody forces, or I mean just gives you the address of the entire hostel, to you just understand rooms, that's all. So you can only refer to the room, you cannot refer beyond that. So in other words, even if a base pointer is getting the derived object's address copied through that base pointer, you can only refer a small portion of it which it has been inherited. The rest remains unaccessible. You cannot access it. Is that fine?
Yes, sir.
So that is how it works. And so it's just one example. As PV is a void pointer, it's a void type pointer, it is null. Now what I do here is PB. So the base pointer is assigned to a void pointer, the derived pointer is also assigned to a void pointer. So in doing so, what do we do? So will this be allowed? So both of these two pointers, if I assign it to a void pointer, will that be allowed? It will be allowed, because void is in some sense it's a generic type. So anything specific you can always assign to generic, but the thing is, once you do so, you basically lose the type information through this casting, because once you do that, now whom you actually casted, you cannot store it. So that way you basically lose the type information. Is that fine? And if you would like to copy it back, PV to PB and all this, so these two are not allowed, because it is again incompatible assignment. A different pointer type you are trying to assign to different pointer type. So that's why, to summarize, implicit typecasting works. Implicit upcasting works. It is safe. Conversion of the derived pointer to base pointer works. Enables access to the base instance or the base portion within the derived object. So this is what we just now mentioned. Implicit downcasting fails. Implicitly it fails, because conversion of base pointer to derived pointer is not allowed. But explicit downcasting works, but it is shown in red because it is not recommended. But non-trivial to know, type in runtime does not model is a relationship. Okay, so I think okay, let us I'll take it in the next class. And I would like to take a class tomorrow in the morning, in the first half. I usually took it earlier also. So tomorrow, can I take a class from say 10 to 11?
Sir, tomorrow we have a class from 10:30 to 11:30, sir.
So that I used to take tutorials, but
Yes, sir.
instead of that, I'll be taking this theory. I mean, this extension of this theory class, because I would like to finish this early. After that, the templates need to be done.
Okay, sir.
So tomorrow, now can I take the class from 10 to 11? It will be useful. I mean, it will be helpful to me, or it will be
Okay, sir.
too early.
No, sir, it's fine.
So I'll start from 10 to 11 tomorrow morning. Okay.
Okay, sir.
Sir, I have a doubt.
Yes.
Will it be the same if B and D has a relationship?
Will it be the same if we have got a? No, you see, in a has a relationship also, it is it will be treated. So again, to generalize it, so even if it is having a has a relationship, it will be treated as if they are unrelated in that sense. So this because in the has a relate, so the distinction is two pointers of two different types implicitly cannot be assigned to each other. That's a general rule. Until unless they have a they are having a easy relationship. So only if they are related by a easy relationship, in that case upcasting is allowed. And in all other cases, like downcasting or in any other kind of assignments, implicit casting will not work. And explicit casting, if you force it, you are inviting uh, problems for you.
So not only for pointers, sir, means for for class objects also.
For class objects also, yes,
Yes.
it will hold true for class objects and also references. Pointers, references, class objects, the same problem occurs, because casting is not allowed. Implicit casting is not allowed. Even in case of reference also the same thing happens. We'll see that in our next class.
Thank you, sir.
Because you are trying to, so what you are trying to do, this is a different entity and that's a different entity. It has got a different, say, it has got different members, it has got different size. So probably it does not make sense to copy one to the other implicitly until unless you make special provisions. Okay, and forcefully doing it, it is not at all recommended. Now the point is this: there is just one case, one and only one case, like this upcasting case, where we know that the derived object, it has got some portion of the base object. So definitely, if you allow it to happen, then through that base pointer, you can just refer to, you can restrict yourself to access only the base portion of it, and that is quite valid. And you are not trying to step out and see the rest of it. So now, whether it is useful and that, and what way it is useful, we'll see that later on. Now we'll say that what's the point of just having access to only the base portion of the entire derived object. So that we'll see later on. Are you getting my point? So let us first see that syntactically, or I mean in terms of writing the steps, what is allowed and not allowed, and then if it is allowed, so that, then what's the point? So you say that the entire derived object is there, and I'm just trying to, you are giving me access to only a small portion of it. And what do I do with it? So that we'll see later on. How it will be useful and why it will be useful at some cases. Is that okay?
Yes, sir. Thank you, sir.
Hmm. Any other questions? Okay, then I am leaving. Tomorrow we'll have the class from 10 a.m.